Hello, everyone, and welcome to this first interview on Java on the Cloud. I've got Oleg here today, and me and Oleg have known each other for a few years. I thought it'd be a really interesting conversation. There's a couple of awesome conversation topics I think we're going to cover today. One is going to be like testing in the cloud, and then some of the AI work that he's been working on. Oleg, do you want to give us a quick intro?
Hi, Mark. I'm so honored to be on the inaugural edition of this podcast. Hi, everyone. My name is Oleg. I am currently with the Docker DevRel team. I work on developer productivity and recently some AI topics. And in the past, I've done quite a bit of work on test containers, which are the open source libraries for managing containers. I'm sure we're going to talk a little bit more in detail. And I worked at Oracle on the GraalVM team, and in general, been a Java developer for, I don't know, 15 years. Like it's maybe even more. So time flies quite a bit.
So, a question that I'm going to ask everyone. Um, So, what is your favorite technical book or favorite blog that you have? What can you recommend to others people listening?
All right. Uh, Technical book is interesting. I like small books and, well, not small books. I like books that can make me a little bit better team player, not particular technical details. So I really, really like this kind of shorter one called Managing Humans. I think it's by Michael Lopp or something like this. And it's a collection of advice on how engineering teams work and how maybe as a manager you can help the team rather than be in the way.
Yeah, that's interesting.
And it's not too like hardcore in the sense that if you are not a manager yourself, I would recommend you to check this out anyhow. Like it gives you a glimpse how managers can think, what are the important problems. So it's good and it reads beautifully. It's a wonderful book. I love it. And for the blogs, maybe I don't have like the particular one. I'm a big fan of the Pragmatic Engineer newsletter by George Lee, which you can find on Substack, but also various engineering blogs, like from companies. Like, for example, when Netflix publishes something about how they do things inside Netflix, it's always a great read. And some people work at those like large, like world spanning companies and have the problems like this. But for many developers, this is a completely different world. So even getting a glimpse and thinking about like what problems do they have, how they approach solving them, how do you build your engineering practices when money is not an issue, right? Like teams like Netflix or I'm sure at AWS or at Google, they have so much talent, so much well, time and money, infinite money, literally, right? They can build anything themselves. How do they choose what to work on? How do they care about productivity? Like it's a wonderful read.
Yeah, I was watching a great video from Netflix, and it's interesting to think of building services, and they use Spring and Java a lot for the services that they have. But some of these services are a million requests a second, which is just just incredible. So, building a web service is one thing, but then handling a million requests a second is something completely different. Cool. We'll put those links in the show notes because I think lots of people will be interested in that. Especially, I think, even if you're not a manager, working in a team environment, I think a lot of us do. And like getting out of that micromanaging, is it done yet? Is it done yet? Loop, I think is probably something that a lot of people can resonate with. So, why don't you tell us a little bit about your career so far? You mentioned Oracle and Atomic Jar and Docker, and that you're a DA. So, how did you fall into this career, and how did you become a DA?
Right. It all started long time ago, more than a decade actually. As of now, I was at an Estonian startup called Zero Turnaround, and we were building tools for Java developers. Our main tool, the main product we had was called JRebel, and it was reloading Java classes on the fly in the process. That was a different time back then. Our applications were larger. We were writing the wave of application servers, right? So you have your JBoss or WebLogic or um, WebSphere or something, right? It's an application server where you can deploy multiple applications, and it brings its whole runtime there. So that was slow to start, and it was kind of like horrible user experience. So like JRebel did like this little magic to load your new classes into the existing process, making the experience what we kind of have now, right? When now you're building a Spring application or a Quarkus application, you just hit save on your files, and then it restarts in like half a second or something like this, right? And you can see the results in action. Like we did that back in like in the
Yeah, because
early 2000s,
those
right?
application servers, they often had like database connection pools that were managed and queues and like authentication systems, all sorts.
Yes. An application server would bring the whole world for you and give you the like all the API that your application would need. And in like you would pay for this by having to have this runtime for you, right? And that you don't manage that, so it would be like probably slow, very much production oriented because people would run them in production. So anyway, we had this developer tool, and we wanted to be like at the bleeding edge of the marketing. We wanted to be cool, and we wanted people to know about us. So we went to conferences, and we had the blog that was quite successful at the time. And eventually the marketing team realized they needed help from an engineer, at least somebody to help with producing technical content, to help educate the customers, to help just answering and like positioning us as the sort of thought leader in the community, and just being generally cool. Because to talk to developers, you need to have this little bit of experience what's like to be a developer.
Yeah, you need to be able to have that empathy.
Uh, yeah, and like it's very very easy because developers are a little bit like teenagers. We are always online, right? And people always try to sell us something because allegedly we are made of money. uh, no, because the productivity is so important that like other people, like management team, will pay if you can prove that you made the life of a developer easier. So everyone sells to developers, and there is very often just a few incorrectly placed words or some emphasis somewhere, and you immediately recognize that you like this is the marketing material trying to sell you something, and then you just switch it off as like an ad block going on, right? So having this authentic developer point of view and being able to talk to developers both in content and at conferences was very important, and they convinced me to join the marketing team, uh, which very finally initially I negotiated that at least one day a week I'm going to be doing still like engineering work. um, and then it never happened. It never happened because there were always so much to do, and also no product teams wanted me to work like one day a week for them because they would be waiting for like a week for me to fix something because I was doing something else. um, so it wasn't great. I still contributed to open source here and there. That was cool. But then it started, and I started doing more conferences. I started learning more technologies that we didn't need to actually use in our like product implementations, right? I started working more with the community, larger community of Java technologies. I started learning more about Spring, for example, and then and that's how it started. And after that, I joined Oracle for the GraalVM team, which was quite amazing at the time. It was very early in the process. I was the first DevRel person on the GraalVM team. Shout out to Thomas Wertinger for finding me. Um, and then we went from an academic project, which was available and sort of on a web page. You know those like university, sort of almost like a university web page where you can download some sources, and we went through the process of making it more industrially acceptable, right? And now it's a growing and amazing
Oh,
open source
I mean,
project that is revolutionizing how Java ecosystem works.
absolutely. I think every single conference I've ever seen has got multiple GraalVM talks. You know, the product and the product lineup is is incredible, and it seems to be growing in every different direction as well.
The team is brilliant, right? And the team is something that I do miss from those days. But after a few years, we launched GraalVM as a product. I put I did my best to try to sort of advocate for using it in the correct context and educating people what it cannot do, channeling the feedback, trying to be there for both the community and to represent the actual engineering team to developers, which is a big part of what the developer advocate is supposed to do. You're supposed to be a channel, because developers in-house and developers who are the end users are very different kind of developers. And with the GraalVM team, it was very, very clear, because it's a runtime, right? A big part of that is, for example, a compiler, where your in-house team is a compiler engineers. They're absolutely brilliant people, but they're also universes away from an average Java developer working in a bank 9 to 5, not being very passionate about technology, for example, right? It's a different world. So that's where the DevRel comes in, where you can translate between the words and sort of make everyone understand each other and pain points and priorities of different people, right? Because sometimes it could be challenging. So anyway, after that, I joined the test containers startup called Atomic Jar that was founded by one of my friends. Well, there were a few people, but the CEO was my friend Sergey. I knew him from Zero Turnaround Time, and so after Oracle, I went to explore the startup life, and it was amazing. We built things, we maintained the test containers libraries, which are quite amazing. We expanded into different language ecosystems there. We built the cloud product, and essentially after a few years, Atomic Jar was acquired by Docker. And that's how I joined the Docker DevRel team. And now after a year of working on test containers and developer productivity, like everyone, I'm also sort of transitioning and exploring the AI space, which is very interesting at Docker as well.
Sounds like a really interesting career, and that career really just spanning all different topics, but the kind of theme is definitely developer productivity, like doing the best we can to deliver maximum value. Super cool.
Yeah, it's very, very nice. The best part for me was that I can developer productivity is something that almost everyone is touched. Like no developer is usually like, oh, I don't care about my productivity. I can do whatever I want. I'm productive enough, right? You can always do more. You can always be better. You can always set up your things better. And specifically with test containers, it was wonderful because we were trying to spread this message that you can have integration tests that are as convenient as unit tests, but can run against very production-like environments. And then you can have a higher level test where one test can exercise multiple code paths instead of just checking the inputs and outputs to particular methods. And I think the more time passes, the more people kind of sort of accept that user experience there is decent enough to warrant basing their test suites in general on sort of integration tests more and more than just being like, oh, we cover everything with unit tests and then whatever fails.
Yeah, and I feel like maybe your role as a DA was maybe a little bit similar to mine as an solutions architect at AWS. Is very diverse. You're talking to a lot of different people about a lot of different things. You're not necessarily part of the engineering team, but you have to know a lot of the engineering topics. How did you find, or did you have any, tools or techniques to kind of keep your engineering knowledge relevant while not necessarily being in the engineering team?
Yeah, I don't have a good answer there, right? So, and one thing, I think the solution engineering is very, very interesting, and it could be the next step for, a natural next step for developer advocate position. right? Because you get closer to clients, you start thinking about more maybe in more market oriented terms, not just the community feedback or like interactions, but the particular value to particular teams and clients. So it's very, very interesting. And like from the point of view, like how do you keep up with all the diverse requirements and sort of do everything? The answer there is that sometimes you have to cut corners, like, and there is no other way around it, right? There is always too much work. You can always be doing more. You need to constantly remember that comparison is the thief of joy. And also you need to remember that what you see online are the highlights of other people's lives, which is 100% true. And you can always look at people and you can see somebody who is everywhere, right? And they would do amazing, and they work very, very hard. Like, I'm not trying to say that they're like not working hard, but it's impossible. Could be only so many Kelsey Hightowers in the world, right? In the Java community, there are only a few people as ubiquitous as Josh Long, right, from the Spring team. You can look at that and get easily discouraged, right? And you can look at yourself and being like, what did I do like last year? Nothing. Like, this is horrible. I should just go retire.
I absolutely agree. I think that's something that I struggled in my own career is that you would see these people, colleagues that I worked with at AWS, and they would talk about some of the work that they were doing, and it would be the culmination of 3 years of work, and then they would summarize it in 15 minutes of talking. But you didn't know that, so it's very hard for you to understand. Oh my goodness, imposter syndrome. I'm not doing what this person is doing. But I think that's very apt and yeah, very important for people to remember.
Yeah. There's also there's half joking, right? But there was a very old, like a decade old article called half-assing it with everything you've got. I'm going to drop a link, and this is not a motto to live by, but it explores this concept. There is the diminishing returns on the effort, right? And it's sometimes very easy to put all your effort in and get as best result as you can, right? You are just, I'm doing my best. I'm dealing with that. This is the best I can do. And after that, you are at peace with yourself. But there is sort of the diminishing returns after some point of time. The efforts don't bring much value, right? So you have to work really, really hard, and then the outcome is not too significant. So, and somewhere before that, there is like sort of a minimal viable result that would be acceptable. So it's very, very easy to put all the effort to try to get as far to the ideal result as possible. But it's very, very hard to put all your effort to only achieve the minimal viable. And it's a completely different mindset. But it also helps very much when you have many things on your plate. Right? You can determine what are the important parts, what are the necessary like results that you have to achieve, and then you put all your effort into achieving those, but you're not trying to go further, or at least yet. And then this way you can manage your energy levels, you can manage your time and productivity, and it also can help quite a bit with various activities.
Awesome. And that's really cool. So I'd really like to talk to you a little bit about the work that you did at Test Containers. I'm a big fan of testing. I love all different types of testing. Throughout my career, I've always put a lot of emphasis on testing software systems. And maybe you could just talk to us a little bit about why you think Test Containers is a really good solution and what the problem space it's trying to solve is.
Right. So from the beginning, test containers are open source libraries, and they're available in different languages. The most popular are covered like Java, .NET, and Golang, and Node.js, and Python, and the PHP recently, and even like Rust, and there's a Haskell library and so on. So what test containers libraries give you, they give you the API to configure, manage, and work with containers. So you can do that from your application code Or as a classical example, you would do that from your application tests code. And in a few lines of code, you can create the environment for yourself and populate the services that your application needs. So I can say, I can import the library into my project. Like for a Java project, I will edit my POM XML, and then I will get abstractions that represent services that my application can depend on. For example, if I need a database, I can say, give me a new Postgres database container and call start on it, and voila, my machine will have a Postgres running in the container, and I can programmatically interact with it. I can configure it. I can ask where it is running, the address, so I can wire that information back into my application. And this way, I can create the environments for application to run from the application code itself, right? So, namely, in your tests, you can create environments for the application tests to run. And normally, you would have the databases there, your message queue, or your Kafka running there. Or if your application works with the cloud technologies, you would run the cloud emulation services in containers as well. So for AWS, there is Local Stack, which is a wonderful project by the company called Local Stack as well. And they have this model of AWS services that are running that you can run in a container on your machine. And of course, that local stack instance doesn't guarantee you availability or performance or any of the actual like production cloud requirements, but it does mimic and model the behavior of the system very, very well. So you can have locally services like S3 or SQS or lambdas or like stuff like this, right? So you can create your own isolated cloud model for your application tests, which is wonderful because then you can run your application and you can make it talk to this service or this database and message broker and other mocked third-party API in containers and the cloud service, and verify that your application works with the configuration that you think is necessary to provide. And the good part is that you can just use your application normally. If it's a microservice, you can just hit the API from your tests, and it will go and write some data in a database. It will maybe send some messages. It will maybe look at the file somewhere in S3, right? And you can exercise like higher level code paths in the application, and you can expect the sort of the business required values, right? So you don't build your tests around like, ooh, do individual components of my app work as I expect? But you actually ask questions like when I hit the endpoint to add a product to my basket, right? Does the necessary stuff happen? Right? You're still in the code, so you can check directly in the database and check like, ooh, the row appeared, right? Or the quantities. Or you can hit another endpoint and see like when I put something in the basket and then I list items in my basket that they will be there. Or if I reduce the quantity to 0, the item should disappear. Right? Yeah. You can actually build tests around the business requirements for the application, and that gives you a lot of confidence that stuff that needs to be working will be working in production.
Yeah, I feel like the kind of classic test pyramid where you write most unit tests and then a few integration tests and maybe a lot less end-to-end tests always had this quite a large chasm between unit tests were always easy, fast running, but also added very little value, and there was always a lot of problems between integration, especially with external services. I feel like test containers makes it a lot easier to test those boundary conditions, and it doesn't necessarily need to be like a perfect mimic of a cloud service. There's a lot to be gained from starting and just trying something out and getting very far before you have to do that last bit of the pyramid, which is the end-to-end test, which might be deployed in the cloud.
Yeah.
I mean, I use test containers for the last few videos that I made for the YouTube channel. So this is basically the what Oleg has been talking about is that I had a Postgres database as a container that was started as part of my unit test. So, with a single line, I've added a database to my Spring application, and then using this dynamic properties source, I'm able to grab the specific URL, password, a username from the container so that my Spring application can access that. And then just as easily, yeah, I'm also creating an S3 service. So, like Oleg said, using the local stack open source library, I'm now basically making, a local mimic of S3. And obviously, I still need to, override my S3 client in a very specific way. So here is where I'm configuring, don't speak to the real S3 endpoint, speak to my local stack endpoint, and use these particular credentials and this particular fake region. But it works really well. I mean, the productivity that I've gained just by using this is fantastic, and I don't have to keep deploying my application again and again. So yeah,
And
really,
there's
really happy.
there's a few things to note here, right? So you get those local stack container or Postgres container as abstractions, right? As the end user, as a developer, you don't need to know how to run local stack or how to run Postgres. You just import the library and you have the sort of the vocabulary to work with this. And it also, the whole configuration is dynamic. So here you run Postgres and then you take the URL to the Postgres dynamically and put it into Spring, which I think in the recent Spring Boot release, this dynamic property source is slightly different. So maybe this is a little bit maybe deprecated approach right now, but it certainly works. But what you can do is you can run these things in parallel, for example, because you can run multiple Postgres in containers, and then every rail of your tests will actually go into its dedicated environment, because you don't, like, if you would run Postgres locally or even in the container, you would do Docker run publish port 5432 to 5432 locally, and then your application will connect to that hard-coded value. You could do that for some setups where you have a few dependencies, right? But because the configuration is static, it's really hard to work with, because you cannot run multiple things, right? You cannot run your development time environment and your tests at the same time, which you can with test containers, because we really try hard to we take care of the cleanup. That's a big point. We want to clean the environment. If you don't want it to be preserved after the test, we're going to clean it up, even if you don't call the close methods by default, right? Because we want the repeatable environment. So you run the test next time, we want the clean environment, so you don't connect to like an S3 bucket in local stack that you created 2 weeks ago, and then you are pulling your hair because there are some files which should not be there, and your test that expects a certain amount of things, or like some file uploads don't work because the name is already taken, or something like random
Yeah,
nonsense
yeah,
like this. So
easily.
we want isolated, repeatable, ephemeral environment for that. Test containers makes a lot of effort to allow that. And also we try really not to collide on the host, right? So if the ports are mapped, which is the resource that is limited on the host, right? You can only bind one thing to the particular port. We try to randomize to like high-level port configs, because you don't actually need to know what the value there is, right? Your application needs to know, and you just know that it's there. You know that JDBC URL is there, but what exactly it is, nobody, the end user doesn't care, right? And you can also build different modules. You can build the modules for in-house configuration. So if you are like a platform team trying to enable productivity for developers, and you're like, this is how we run Cassandra at our company, right? You can build a module so all the application developers can be just saying like, new my company Cassandra, and they get the config. You can plug it with observability if you want, right? You can have your particular config. You can make sure that your module definition kind of sort of mimics your production systems to the better like degree than maybe the community modules. You can also run multiple containers at the same time and pretend it's just one container. Well, for example, the Microx, the CNCF project for mocking API does that, right? When you start Microx, well, you start the Microx ensemble of containers. So there is a hint that actually will be more than one, but they start different like API for like different containers for different parts of what needs to be done, which is kind of cool, if you
Yeah,
ask.
super cool. Yeah, I mean, big fan. I'm loving like the collaboration and the ease of use between test containers and local stack. And yeah, I'm gonna continue to learn it. And I guess you just hinted that I've been missing some updates, so maybe I'll check my code sample and improve it.
Yes. And it's also like, so it's not just Java. I know that you are like, this is Java in the cloud, right? So we are Java oriented. But if you're working with different languages, or you have your less fortunate colleagues working in different languages, you can recommend test containers to them. And there are many different implementations. And one thing recently, for example, that was a very good step forward. So in Java community, most of the application frameworks know test containers and they integrate with test containers quite a bit, right? So you run the Spring Boot application, you can have this test application facility where you don't even run the test, you run the application itself, and it will create the environment for you using the same test containers based setup, which is great because I can clone my application, I can run it, and it works. I don't need to care about the configuration. It's all there. It's all in the code. It will never get out of sync. I don't need readmes. I don't need to read like 10 Notion pages. It's just clone and run. Or Quarkus with the dev services, the framework that actually I think they popularized and implemented dev services like actually first in the ecosystem. Which is where you run the application and it needs a database, but you don't provide the configuration for one. And the Quarkus application is like, you know what? I need a database. You didn't give me one. I'm going to spin up myself like a Postgres container if you have the Postgres driver, because I want to work. And it's a beautiful concept, right? So this development time environment. And just recently, Manu, who is the test containers Go maintainer, wrote a blog and shared with me that now there is an integration with Fiber, which is the Go sort of framework for writing web applications, or application framework, if you will. And you can get the same sort of ease of local development setup in Golang as well.
Yeah,
So it's moving and spreading into other languages.
I mean, I've never seen a company that only uses one language. I mean, when I asked, any company which language do you use, it's like every language. And I think that's pretty typical of any company of any size. And to have the same testing approach or testing strategy across different languages, I think would be a plus. So fantastic that you've added different languages, not just Java.
Yes. There is even PHP.
So maybe let's move on. So test containers has moved. I was being acquired by Docker. What's your role changed now that you're working with Docker? You're obviously still doing some test containers work, but what else are you working on?
Right. So it happened like a year ago now, more than a year ago, actually a year and a half. Time flies. It was December, and it was a very nice Christmas miracle. I think it was very very strategic acquisition for both parties, especially for Atomic Jar, because test containers always depended on having the Docker environment present, right? This is how we run the containers. Test containers modules, those abstractions are just wrappers around particular Docker images. So there is always a very, very tight technical collaboration between the technologies. So there could be no better place for test containers than Docker. And I think Docker got a very vibrant community and a very, very good approach to integration tests, which I think brought Docker team also a little bit closer to appreciating and like being very very aware of application developers, right?
Yeah,
Because
it's a fantastic use case for Docker is an amazing use case for developer productivity, and test containers really showed that feature really well, I feel like.
so I think it was very very good, and I personally joined the DevRel team, which is quite amazing. We are doing a lot of work internal facing into Docker, working with customers and working with some marketing materials and so on. I still do a little bit of like kind of sort of conference presentations and content. But in addition to test containers and developer productivity, I started diving into AI topics as well, which is very interesting because Docker has a couple of fascinating projects that can I think they fit the narrative of Docker being the developer enhancing productivity tool, like a suite of tools, very, very nicely.
Yeah, a single way of running dependencies and running external resources.
Yeah, so Docker, like, of course, you can run anything in containers, right? And then that was for ages. And up until last couple of years, like all we ran was software, right? But then one spring, everything changed and everyone started going crazy about AI workloads. And it's a little bit awkward to run AI components in containers, namely because, well, for one, there is no, it's hard to give access to the GPU on all the operating systems. Macs for a long time suffering was like you cannot pass through GPU to the container workloads. So, and it's also unclear how to run, say, a large language model locally was just a bunch was within containers, or how to even develop applications that rely on AI, or is it a thing? So now for a while, people were looking at this and running like how to run models locally, and now Docker has the feature called Docker Model Runner.
Really interesting problem recently because I was making a code sample which used Postgres database and Amazon Recognition, which for those who don't know is an image analysis cloud service. So I was checking profile pictures that have been uploaded to my service to say, did they even have a face in them, and were they offensive in any way? And I was like, oh, I can't actually run this in local stack or in test containers. I'm going to have to call the real service.
Yes,
Actually, this is kind of annoying.
it is because you need to manage the keys already, right? You need to either different account or some namespaces in the cloud. You need to be conscious of the budget, and you need to make sure that you don't you have your alerts set up, because like if you manage just the production secrets, that's one thing. But like if all your developers need additional secrets to access your like production cloud service, you need your security be on point and so on. So AI becomes like more ubiquitous in our lives, right? And most people have this ChatGPT experience. Maybe not everyone yet is building applications with some AI component, but there are a ton of fuzzy problems that you could, right? As you said, maybe validation that your like user input is appropriate and good. Maybe you want to send like personalized marketing emails to people that are segmented automatically in your database, right? You add a product, your AI looks at who could benefit from that, crafts emails to them and sends, right? At the same time, you will need to check that those emails are correct and like appropriate and nice. Um, so your system doesn't send emails like, oh, buy this, you idiot. Uh, which might work for some demographics, but maybe
The image that you want to portray.
yes, it depends, right? So or like even the small fuzzy things, like when you paste an address, right? Like you need to separate it into like various components, like it's a medieval time still. I'm not sending a pigeon. I want to paste my address, and I want the system to just actually split it correctly into the parts. I think you can very easily do that with AI, and you don't even need to have like the all powerful like latest chat gpt like OpenAI model to do that, right? It's a basic text manipulation, so you can have a much smaller model to do this. So there's this whole idea that local models or smaller large language models can be the the go-to component for your AI components. And there are some examples for this, that the world is moving there. So recently Netflix published a blog how they trained a small large language model to do the recommendations. So like in the past, like machine learning tasks were done by machine learning engineers, like teams training specific models that would be like, oh, you give the input in this way and then specifically the output, and then something happens, right?
Do the training with this training data or specific.
Yes. So, and it would be hard. You would need to actually understand what the machine learning model is doing and things. But now, thanks to this like commoditization of AI, now I think we can do very many things with the just general purpose large language models, where we describe the tasks as text, maybe specific text. Maybe you do need to do prompt engineering there. And not all the tasks, maybe you need to still, maybe it will be the overkill, right? Maybe like if you need to look at a picture and determine whether there's a frog in the picture, maybe you can have a very small, neatly packed like frog detection model that would be like optimal for that. But also you might have like a smaller large language, like large vision model to do that, right? It's perfectly fine. And now as a non-AI engineer, I can maybe build some of the stuff like that. And then, so Netflix did that for recommendations. And I think they did that was a couple billion parameter models, right? So a couple billion parameters is not a lot. Like the cloud models, the OpenAI models are like hundreds of billions. And even locally, like you run the models, it could go into like double-digit billions of parameters quite easily.
So I'm always a kind of frugal developer. My machines are always kind of old and a bit rubbish. So I've got one of the new Mac Minis. Is that something that I can run locally? Can I run?
Yes. So if you install Docker Desktop there, right, you will get the Docker model runner. You might need to enable that in the feature set in the settings, but you can run the models. How much unified memory does it have? 16. So 16 is not a lot.
I need
Like
to upgrade. Okay.
yes, so 16 is not a lot. You probably will be able to run something like 8 billion parameter models. And there is the whole like this ecosystem of models, and so it's a matrix, right? Oh, well, like it's a bunch of matrices, and you do multiplication all the time, right? So that's what in a nutshell happens. And then the values in the matrix are the weights, right? And those are floating point values, right? And then during training, they are changing a little bit to like give you good answers on like range of inputs and outputs, right? Which is what essentially the training is. And then during inference, you run the input through this matrix and you collect the outputs on the other side. So there are two ways to scale this down or up, right? You can have the larger matrix or like more matrices, which is the number of parameters. And then the smaller models will be like around 1 billion or a couple billion parameters. And sort of the maybe smaller but capable models will be around 8 or 10. And then sort of there is like 20 something range, and then sort of 70. And then like higher. And then we'll have DeepSeek at like 670 billion parameters. This is one parameter, how big the matrix is, how much knowledge can it store in the weights. And the other parameter is quantization, which is you can dump down the matrix by replacing the floating points with shorter floating points, or with integers, or with shorter integers. And surprisingly, the model still retains the some intelligence there. So that's called quantization. And then, for example, if you run something at quant 4, Q4, and with some numbers after, that means that all the numbers, all the weights are compressed into an integer of 4 bits, which is from 0 to 16, which is crazy. It shouldn't work, right? It shouldn't. But it does, and it still outputs the sort of coherent text. It's just more chaotic, right? So even at the smaller machines, maybe you have you can play with the quantization versus the size of the matrices. But I would assume that 16 is a little bit small, right? Like would prefer something larger, or you can try with a smaller, maybe 8 billion matrices, 8 billion parameter models at some quantization levels.
Yeah, because at some stage in my development process, I'm not necessarily wanting to test whether the model, is outputting the best possible answer. There's a certain stage of the development cycle where I'm actually testing the integration, testing things like observability, performance, security, things like that. And the swapping of the model, is typically now, we've got lots of different models for lots of different things. We can we can probably swap that out if we need to in the future. But having something locally that I can test and integrate with is
Yeah.
is cool.
And you can also have the same setup in your CI environment, right? So Docker Model Runner runs on Docker C as well. So you can put it in, and then for application building purposes, what you would have different kind of tests. You need sanity tests. So you need to have a local model that sort of understands you, and you're like, yeah, it does give sensible responses sometimes, right? Like to some inputs. And then you hope that the larger model that you run in production maybe is even better, right? Like locally, you can, for example, run maybe Gemma models from Google, and then in the cloud rely on Gemini, or I don't know, Anthropic, or like Mistral, like as the European model. Mistral small runs locally, or like Devstral or some other local open source models by Mistral, and then rely on them in production if you want a cloud service, if you don't want to deploy those same exact models into your own data centers. So you do that, you verify the sanity of the model and your prompts and the combination of the data that you send, and then you build a lot of integration tests against the mock of the AI, because you do want your application to handle failures, right? And you don't want to have the test what happens when model hallucinates complete random, or what happens when the latency is slow, or other sort of negative paths, which we sort of learned during normal software engineering that is the way to go. But when you are very hyped, and when you see people on social media YOLOing things into production like there is no tomorrow, you might want to do the same. But what you should remember is that it is still software. It's like you are building applications, right? It's like the lessons we learned from building software are still valid, and yeah, you should have the test. You should have some sort of pipelines. So 6 months after you YOLO something in production and it breaks and somebody comes find you, you will be knowing what you actually did because there
Yeah,
are some tests.
it's the same thing, right? Failure scenarios. What happens if the service returns an error? But also, these are often services that have thresholds. They have throttling limits, and if you haven't built a system that has hit a throttling limit before, or if you're not used to using services that have throttles, these ones do, and that's definitely something to be taken into account. What is your service going to do when you hit a throttling error? Is it just going to stop working, or is it going to work in a reduced way? You know, Instead of using this big fancy model, you could use a different model as a fail-safe.
Yeah, maybe routing to some local models. Maybe you just uh, maybe you just stop for a time being and output error messages, or maybe your application just crashes, right? And then there is an engineer like while they're running to getting the page that's everything is down. So this is interesting. So Docker, like because people are building applications with AI, Docker has built this Docker model runner that you can run it on Mac OS. The models are stored on Docker Hub as OCI artifacts. So there is no compression, and it's a nice way you can get models from Hugging Face, and you can push it to Docker Hub yourself or your internal registry if you want, right? So there's the distribution component for models. There is a runtime component. We are currently using Llama CPP as the backend, but the architecture there is flexible enough so we can build something else in as well. And yeah, you can run it on Mac OS, you can run it on Windows. With NVIDIA cards, you can run it on Linux. so you can build it into your CI environment. And in general, what we want to have this be the integration point where whether you're running software like databases and stuff, or whether you're running AI components, like the user experience is no different. With Docker, you just say like Docker run and or Docker pull a particular model, and then it is there, and you can rely on that. You can connect your applications against that, or you can connect your local assistants against that, and it would work beautifully. Yeah.
Docker Hub has always been this central point for kind of accessing, external services. Like, you can always find like a Postgres database or a so and so. It's always been a very good place to have as a central point of access.
Yeah. So you can look at Docker Hub, hub.docker.com/user for AI, and you can see a bunch of models there. And as I said, you can get models from Hugging Face and push yourself, and then you can pick what exact quantization you want to transform and run, so you can make it available for your hardware. Oh, and a cool bit, right? You get a test containers module for accessing Docker Model Runner. So it will give you the URLs correctly, and there are some slight differences between how it runs on Linux and like on your Mac, for example, right? So if you build application tests and you want to work them at all machines, you can use the test containers module. It will handle the URLs for you correctly. And there's also a thing called providers in Docker Compose, where you can say, I want to rely on the LLM, and you can say what LLM you want, and if it's not there, the same as with a Docker image, right? You define a service in Compose file, and it will pull the image and start the service. Here you can say like, I want the provider on that model, and then this is the model that I want. It will pull the model, start it, and then make it available, so you can have your sort of environment and the user experience that you are used to, right? You shouldn't sacrifice user experience just because you are doing AI now.
Yeah, this is the thing with the new technology. People are finding ways of integrating all these things and bringing them into kind of standard engineering practices, but there's always a delay between the hype and everyone running forward and actually the reality of hold on a second, does this meet our normal high standards of engineering?
Yeah. And it's very, very interesting where we're going to go. So Netflix is building smaller models. Wiz recently released a blog post how they trained the local model for like secrets finding in the code bases, because it's just working with text, right? And sometimes you do call your variables like API key, and then it's easy to spot. But sometimes it's not, and then it's unclear. So they are building that, and I hope and I think we're gonna see more and more companies using like large language models small large language models for the particular problems, instead of training like the sort of machine learning models from scratch for the particular tasks. And I think it's very interesting direction where the application building can be going.
Awesome. So we're coming to time. Is there anything else you want to mention to people before we head out,
Uh,
Oleg?
well, Docker has more about AI. So there is the MCP toolkit catalog of MCP servers that you can rely if you want to build local assistants for the models. Because this is sort of like running other people's repositories on your machine. Maybe not the best way of going through life. So if you're building local assistants, AI assistants, take a look at the MCP toolkit. But in general, if you would try Docker Model Runner, there's excellent integration with Spring AI, excellent integration with LangChain4j, so you can use it from your Java applications very, very naturally. I'd love any and all feedback, and just don't forget to test your applications.
Awesome. So lots to take away from there. I'm certainly going to try out Model Runner. I've been looking at Spring AI for a future video, so maybe I can combine the two. And thank you so much for joining us. It's been really cool to chat with you again, Oleg. See you soon.
Thank you very much for having me.
Bye.